Alright guys, we're going to be talking about cladograms and dichotomous keys today. We'll learn about them today, we'll practice them a little bit today, and do a lot more practice tomorrow. So a cladogram is a tool that scientists use to group similar objects, and a dichotomous key is a tool that scientists use to help identify a specific object. So they're very similar, they're going to look similar, but slide number 6, I've got this up here. I want you to take notes on slide number 6. You should already have some notes here. You can add cladogram to this, and you can add definitions to it as we go along. If there's something that we learned that you did not know before, or something that you think might be important, or that I mentioned, slide number 6 is where you need to be taking your notes for this unit. So let's go down to slide number 11. You need to copy slides number 11 and 12. They're about cladograms. This is your assignment today, part of the assignment, and your reflection is going to be based on this, that you need to be able to prove that you can use a cladogram to show and understand relationships among different organisms. And so you're going to answer numbers 1 and 2, and then on slide number 12, A, B, C, and D. So I want you to go ahead and pause the video in just a second. I want you to watch on your slide number 11 and I believe slide number 12. There's a playlist here. There's 2 different options for a video. There's a video that's says Cladograms Explained, and then there's a version 2. I think version 2 is going to make more sense to you. But you go ahead and watch that. Pause this video. Go get that video. Watch that video so you understand what a cladogram is and how to use it. So hopefully that makes sense. Hopefully cladograms make sense on how to use them. This is just one example. Most cladograms are going to look something similar to this. It may have 5 or 10 organisms, and it may have little branches that are coming off of this, but this is generally how they're going to look. It's a branching diagram that shows clades or groups of organisms. So let's get into dichotomous keys. A dichotomous key, I'm going to put this full screen so you can see it better. A dichotomous key is a tool that scientists use to help identify an organism. So let's say that you had what you know as a reptile, but let's say pretend you did not know that a lizard was a reptile, or an iguana, or whatever is a reptile. In a pile, let's just say that all these organisms, mammals, birds, reptiles, fish, amphibians, all of them are in a big pile, and you're trying to figure out, what is this organism? Is it a bird, or is it a fish, or is it an amphibian? So all of those organisms are vertebrate. They all have vertebrae. And so your first question is, does it have fur? And something you'll notice about all dichotomous keys, every single dichotomous key has 2 options. Sometimes it comes out like this, looks nice and neat. Sometimes it may have an arrow that comes out of it. Maybe it has arrow that comes directly out of the group from above, but it's going to have 2 different legs to it, 2 different options. It may be yes or no, or purple and not purple, or living, not living, if we're talking about non-living objects. It's going to have 2 different descriptions. And one description will lead you to, generally it's the left, and one description will lead you to the right. So in this case, does it have fur? If it does, then what you have in your hands is a vertebrate that has fur. It's a mammal. But if the vertebrate does not have fur, then you go over here and you haven't identified it yet. You have to answer another question. Does it have feathers? If it does, then it's a bird. If the answer to does it have feathers is no, then you have another question to answer. And this dichotomous key, it keeps saying no, takes you to another question, but not all dichotomous keys are like this. Not all dichotomous keys have no lead you to another question. Some dichotomous keys don't even have a yes or no question. It's just this group or not that group. So if it doesn't have feathers, then it asks, does it have dry skin? If it does have dry skin, then that is a reptile. If it doesn't have dry skin, then you have another question. Does it have scales? If so, then it's a fish. If not, then it is an amphibian, like a frog. And so this is one example of a dichotomous key. Here's another example of a dichotomous key. And both of these, in math, you call this a tree diagram. These tree diagrams, it's essentially a tree diagram version of a dichotomous key. And we'll look later at what another version of the dichotomous key is. So this one is has fur, yes or no, has feathers, yes or no, does it get fertilized on the outside, yes or no, and you keep asking the questions until you get to an organism. So if the organism you have has fur, boom, you're done. You don't have to answer any more questions. This is the first question. You don't have to answer any more questions. But if the answer is no, And you go over here, you have a second question, and a third question, and a fourth question, if you keep answering no in this case. Here's another example. Let's pretend you don't have these leaves. These leaves are not on the paper. Erase the leaves completely, all 5 leaves. If I gave you this dichotomous key and took you outside, and these 3 trees were outside with leaves on, you should be able to tell me what is a plum tree, what is a locust, what is a weeping willow, what is a ginkgo biloba, and what is a pin oak, based on the leaves out there. So let's say you had a leaf. Let's pretend like between you and I, you know it's this leaf right here. So you have a leaf in your hand. It says, is the leaf purple? Yes. No, it's not purple. So you say, it takes you to this one. This is question number 2. It says, is the leaf very thin, much bigger in length than in width? Then the answer is no. It says, is the leaf shaped like a fan? If you look at the leaf that would be in your hand in this situation, then you would say yes. And so then you know that it is a ginkgo leaf. So this was another yes or no questions, but it's sometimes yes led to more questions, sometimes no led to more questions. But you keep answering the questions, and you go, you follow the correct answer, and you keep going down until you get to the end, like a terminus or the end of the road. And there will be a picture or a description or the name of the object you're looking at. This is an example that we did in class. We made in class. So let's pretend like you didn't see me just move those. This is a little bit rougher because we did it in class very quickly. So weird shapes. These are all weird shapes. Does this shape have a rounded edge? Does it have rounded edges? Yes or no? If yes, well, the class that did this one, they named it Gary. So that name of the shape is Gary. This one. Does it have rounded edges? No, it does not have rounded edges. Okay, is it brown? No, it is not brown. Does it look 3D? It looks 3D? The answer would be no on that one. This does not look 3D. It looks two-dimensional. So that is Jimmy. It's a septagram. It has 7 points to it. So really weird-looking shape. It looks like there's 2 squares, but you keep following along, and it's not 2 squares or 2 weird parallelograms or quadrilaterals. All right, let's look at this one. Uh-oh, what happened to it? Disappeared. Oh no. But that shape, it did not have rounded edges. It was not brown. It did not, and it does look 3D. So that shape, where it just disappeared somewhere on the slide, I'll have to find it. But that shape is an Escher shape. If you were to look back here, that's what you would see is an Escher shape. And this one on my screen it looks brown. I'm hoping that's what it looks like on yours, and it disappeared again. I don't know what's going on with these. I'm not sure where it went. But that was a brown arrow, so it says, does it have round edges? No. Is it brown? Yes. That one's name is Franklin. I'm not sure when I move these. They're disappearing. I don't know what crazy stuff's happening. But, yeah, so that is how you can make a dichotomous key. And if you'd like to look up, you can look up some other people describing what a dichotomous key is on YouTube or something like that. Go to Khan Academy. That's a really good place. But that is how you make a dichotomous key. Okay, so something that you need to practice is get 4 objects. They can be really similar objects. They can be completely different. Something you can eat, something that's living, something that's not, something that's large, small. Just get 3 different objects around your house. Probably smaller objects would be better just so you can do this easily. But get 3 different objects. And I want you to set them on the table, and I want you to split them up into 2 groups. Not just randomly, pick these 2 and these 2, or these 3 and that one, but put them in 2 separate groups and have a reason. So come up with a question, kind of like I did with the thing, is it have rounded edges? So you can do shape, you can see, does it need electricity, does it smell, is it edible, can you pick it up very easily? That's probably not a very good one, but come up with different questions, ask a question, and you can make it a yes or no question. That may be the easiest thing to do. Or if it's a color, does it have purple on it or not have any purple on it? But make it a question, whatever it is, that if you ask that question and you gave that object to any 50 people, all 50 people would agree yes or no to the answer. If it's something like this is cute, or this is big, or this is ugly, or this is nasty, those are not questions that are very good because they have an opinion, a very strong opinion behind them. They need to be definitely factual. This is 6 centimeters, or this is red, or this is rectangular in shape. It has sharp sides, whatever. I want you to do that with the 4 objects, split them up into 2 different groups. And then I want you to continue asking questions, making a dichotomous key, kind of like I have on my screen. Continue making a dichotomous key, or to continue asking questions until each one is on its own. And then what we did in class is we wrote on the desk with chalk, and we wrote a name. Everybody wrote a name, just made up a name. These were all guy names. You can come up with girl names or made-up names in Spanish and Portuguese, whatever. And then take all the objects back to the back and have somebody, a sibling, a parent, a friend, come and see if they can figure out what you named each object. And they should be able to go down the dichotomous key just like we did, and they should be able to identify each object and give you the accurate name for each if you did your dichotomous key properly. And tomorrow we'll do some practice pages. We'll look at writing these and turning these into more of a written out, step-by-step dichotomous key, but at least now you understand the general idea of what dichotomous keys are and how they work.